All right, we're live. So in this video, I'm gonna do a simple animation in Pygame, kind of extending what we covered in the previous video. And just to save some time, I kind of put in the core bit of code. So I'm importing Pygame, I'm initializing it, defining my surface again, 500 by 500. I'm giving it a title, video 2, and then I have the event loop, where this bit of code is just so that if I hit the close on the window, it'll go away. Here I'm filling it black, and here's kind of the update. And then when it's all done, I quit out. And let me just save this, make sure it's up to date. And then I run it, and I just have basically a blank screen. And so the animation I'm going to do is just a bouncing ball. But I figured I would start with kind of a bounding box. So what I can do is do Pygame. Actually, let me put the coordinates in. So I'm going to do Pygame. Draw, and I'm going to do lines, and I'm going to do surface, and I'm going to pick my color as white since we have a black background. I'm going to actually connect the final point so it's true, and then I'm going to do points, and I'll put this in a second because I just don't want to type it here. And let's try a line width of 2. And so my points is going to be an array of things. So I'm going to start with 100. Get out of there. Get the volume. So 100 by 100, and then I'm going to go 100 to 400, and then I'm going to do 400 to 400, and then let's do, what is that, 400 to 100. So let's just take a look at this, see if I have any errors, and it runs, and now I have a bounding box. And what I'm going to do is place a ball in here, and I want that ball to kind of bounce around in this, and kind of similar to your kind of homework example. So let's come down here. Let's do an XY position, and let's put it in the middle of the box. So we'll do 250 by 250. And let me just draw the ball. So I'm going to do Pygame, draw, and then I'm going to do circle. I have surface. And now my color, let's make it a red ball, 0, 0. And then I have the XY coordinate. So if I run this, let's exit out of here. So I got the quit, and then I come back here, and whoop, position 4. Oh, I forgot the radius. So let's pick a radius of 25 as the last argument here. So I run it, and now I have my ball in the middle. And so what I'm going to do is start moving that ball, and what I want to do is have that ball kind of bounce around, right? So when it hits here, it's going to reflect and hit here and reflect back. I think 25 is a little bit too much. Let me pick a radius of 10. That probably looks better. And let's just run it one more time, make sure everything's good. And so now I have my ball here. So first thing I want to do is I'm going to define some velocities. So I'm going to do a v of x, and maybe I'll set this is equal to 2, and then I'll do a v of y is equal to 1. And so that's going to be my initial velocity. And so when I do the surface, right, so it's going to do, right, I have my bounding box, I have my ball, I draw on the xy point, and then maybe I can update my x and y position. So I can say x is plus equal to v of x, and y is plus equal to v of y. And so now, whoop, let me get out of here, get the Control C, and make sure I have this saved, yes. And so now I run it, and my ball is just going to kind of disappear off the box, right? Because it's not, we haven't put any conditions on the bounding part. So the easiest way to do this is we can just put some, conditionals. So we know our box is from 100 to 400, so I could say if x is bigger than equal to 400, or x is less than equal to 100. And then I'm going to actually subtract 10 here. Let me put over here, minus 10. And this is going to count for the radius of the ball, right? And then this is going to be 100 plus 10, all right? What I'm going to do is simply flip the velocity. So basically, the ball hits the wall, and the velocity is going to change. It's basically its sign. So I can do v of x times minus 1. And then likewise, I can do the same thing for my y variable. And then this is just going to correct everything. So here's my y. and then I can do y here, and then I can do v of y there. And so let's just take a look at this. We run it, and now I have my ball, and it's bouncing around, right? Kind of, all over the place. And because I have kind of unique characteristics, it's kind of doing a defined pattern in here. So it's a little bit choppy. And so what we can do is come up and we can start trying to determine kind of a little bit of the speed on this and kind of determine the frames per second for our simulation. So let's come back to our code. So we have, again, this is kind of the wall collision detection. Here's kind of our update in our positions. We could probably put this below. It's not really clear which one you want to do first. But let me define a new variable. So we're going to do clock. And we're going to come over here. We're going to do clock. And it's going to be pygame tick. And then we're going to type big old clock here with a capital C. And not a capital L. Let me make sure that's right. Check my notes. Yes. And then down at the very bottom, as I come down here, after I do the update, what I'm going to do is type here, I'm going to do clock, I'm going to do tick, and I'm going to determine how many frames per second. So let's do 10. All right, this is pretty slow. So now when I run it, whoop, has no, what am I doing? Clock.tick. I must have typed something up here. Let me figure out what my error is before I get going. And I have to just peek at some other code. So I got pygame. Oh, no, it's pygame.time. I'm sorry. I'm surprised it didn't give me, yeah, here's the error. All right, so now we run it. And now my ball's moving very slowly because we're basically looping, going through this loop 10 times per second. And each time we're moving, we're moving position X by 2 and Y by 1. Now, obviously, what I could do if I want to speed it up is I can maybe make these variables bigger. So I'll do let's do 7 and 4 just to pick some arbitrary numbers. And if I run it, now it's kind of like, if you notice, it's a little bit choppy because we're kind of jumping too much, right? And this is like if you're doing the flip book and the neighboring images are too far apart, it doesn't have that kind of seamless transition in the animation. So again, you kind of think about this as a flip book. At least that's the model I have in the back of my mind. So let me come back and let's just shorten this down back. Let's do 1.5 and I don't know, let's do 1.1, maybe get a little bit more interesting shape going. So actually now it's gone real slow, right? And it's going to start bounding around. And so this is kind of too boring to watch. So let me come back here. So here I just picked the arbitrary velocities. So now maybe I can try 60 frames per second, all right? That's kind of the standard. And so now it's kind of moving, it's bouncing around, moving with a certain speed. Now I can speed it up a little bit by increasing the frames per second, but my experience with this is that, like, if I go to 600, let's pick something, it's not going to move that much faster. Yeah, a little bit faster. So I don't know if it's actually moving 600 frames per second. That seems a lot. But you can kind of play around with the speed, and it kind of makes it consistent, right? If we look at the velocity, slow down a second probably because my CPU is running. And this is being done on a laptop, right? So you kind of get that kind of glitchy side. So if we come back here and maybe pick, 100, maybe we'll probably get a reasonable simulation out of this. Most of the examples and in the homework problems, I think I use 60 frames per second for all of them, and that kind of works well. And, this moves fast enough so you can debug it. So one just extra thing that I did here is notice when the position of the ball, this XY determines the center of the ball. And when I do the collisions, I'm correcting for the radius. And if I took that out, so if I did something like, let me just put zeros here so I don't have to make too many changes, and zeros, and I come back, what you're going to see is it kind of goes past it, right? If you notice, the center kind of hits the wall here, here, and so on. So that's why I added the extra 10 in case you were wondering where that came from. So I can kind of put it in these 10s here, 10s, 10s, and let me just save that. And let me eliminate out this. And so now I have kind of that basic simulation again. So that's kind of just a quick overview of animations. Now, obviously, we could do multiple objects in this. We can make it much more complicated, right? We don't have to have just one thing moving, so I can get a little bit crazy. So maybe I could add like, I don't know, like I did before I did this I increment. I could do I of equal to 0. And then I can maybe come over down here and say I is plus equal to 0.001. And then I could just, add I here. This would be a lot easier, of course, if I had done this as a NumPy array, which you can do. And in some of the more complicated examples, you actually have to. But if I come over here, I can start moving multiple objects. And so if I run it, you're going to see that it's bounding around. And then kind of the box is kind of shifting on us. Actually, we could kind of clear this up. So if I came back here and I put 400 plus I and 100 plus I, actually this should keep the bouncing within the moving bounding box. We'll see if this works. So it's shifting and now it's bouncing. It's getting stuck. Sometimes it'll get stuck. We'd have to probably do a little bit more corrections on that. I'm actually not going to do this. But so you can play around with lots of different ways of doing the simulation. And I think I will stop there. Let me just take out the I. Maybe that was a mistake to do, but the key point here was that, you can move multiple objects, right? So in your simulations, I think the first problem I'm going to ask you to bounce around, in your first homework problem, bounce around like 30 balls. Kind of similar to this, except you'll have to do kind of collision between those balls. And it's just going to be a lot of if-then statements, and then you can loop over the different number of balls that you want to put into the simulation. So hopefully that was informative and kind of gives you a sense of kind of playing around with Pygame. It's kind of nice. It's not a lot of coding. And, it's really what you do with it is kind of limited by your imagination. And so with that, I'll stop. As always, put questions in the comment section or post them on Piazza. Thank you.